Okay, so welcome to this talk on API management for GraphQL, and thanks for having me and arranging this talk. My name is Fazlan Nazeem. I'm currently working as a technical lead for WSO2. I'm based here in Sri Lanka, but we do have an office in Sydney as well. But most of our engineering happens here in Sri Lanka. I've been with the company for about 6 years now. And for the most part, I've been part of the API management team. So my journey with GraphQL actually began when we first started doing API management for GraphQL. So the goal of the talk is to actually share some of the lessons that we learned, and also to educate you guys on what to look for when you're choosing an API management platform to manage a GraphQL service. Right. So this is my email address and Twitter handle. Feel free to reach to me for any inquiry. Right. So I have a short agenda here. We'll first look at what API management is, and then we'll look at what GraphQL API management means. I tried to squeeze in a demo as Paul said, but the time, I had a timing issue. So I've added some screenshots, if that's okay. And then at the end, we'll have a short Q&A session. Right. So what you see here is a normal client to server communication, right? So you have the client on the left and a service on the right, right? The service it lives remotely somewhere remote. And assume that you are a developer who is developing this service. So assume that you and your team have completed the implementation of the service, like all the business logic is complete, 100%, and the testing is complete. And now if I ask you a question as, is the service ready to be exposed to consumers? Uh, if I ask you that question, there are several things that come into play, right? So have you thought about authentication, right? How do you authenticate the incoming API call? How do you validate who is calling your API? And then even though you validate the user, that user still might not be having sufficient permission to invoke the API or the particular resource. So that is what we mean by authorization. And then are you going to allow unlimited number of requests to your service? Or do you need some level of control over who gets how much? And then analytics. So once you expose, you should probably know what's happening to your service, right? So how many requests do you get, and from what types of applications, from which geographical locations, all those metrics become important for business insights. So I've named them as cross-cutting concerns because these concerns apply to all types of services, right? So it's not just for a REST API or a GraphQL API. So these things apply to all sorts of services, regardless of what type of API it is, or what protocol it is, what programming language is being used, and so on. So now, when you're thinking about implementing these things, uh, there are like all sorts of libraries, frameworks available to implement these things at the service layer itself, right? So for example, if it's Java, you can do it with Spring Boot or Ruby on Rails or whatever the programming language stack that you're using. These do provide capabilities to implement these things, at least to some extent. Now the problem is, now if these things or the requirements of these concerns are also constantly changing, and also if your organization has a lot of services, then managing these implementations is going to be difficult. You have to put extra engineering effort to maintain these things. And also, we know that with the microservices architecture and everything, now organizations are adopting various types of programming languages, protocols, all this polyglot architecture coming into play. So with this reuse is also becoming a little problematic. So now this is where API management comes in. So what API management is going to do is it's going to introduce an API layer in between. So you have your client application and your service. Now you have the API management layer in the middle. So now all the requests from the client application to the service now flows through the API management layer. So this means that you could offload all those things that I said before, all those responsibilities from the service layer to the API management layer. So that the service developers can just focus on the business logic of the service. So once you do that across your organization, across all of the services, so this is how it's gonna look, right? You have various types of applications trying to talk to a single API, and you could see that the service is connected to the API in between. So all the traffics from the application to the service actually goes through the API management layer, uh, and it cannot bypass the API management layer and just connect to the service. So this is why the API management layer becomes a good place to enforce all sorts of policies, because now all the requests go through this layer. So you can see on the left, I have another illustration. Like you see that various types of application, talking various types of protocols and various data formats. They are talking to various types of services on the bottom, and all those requests are flowing through the API management platform. Now, there are various other things an API management platform provide. So I have picked a few. This is not an exclusive list of all the features an API management platform provides, but I'm going to explain a few. So you have, first of all, API lifecycle management. So what it means is that you can manage the lifecycle of an API across states. For example, initially it could be in the testing state, and then it could move to development, and then in the prototype state, then publish. You could temporarily block it, and then maybe even retire it later if you don't need it. So all these state transitions can be easily done uh, at an API management product. So then the aspect of security. We already talked about authentication and authorization briefly. So even for those things, there are various flavors that you could do it, right? You could do auth2, uh, mutual SSL, basic, all sorts of flavors that you could do authentication. And then it's not just authentication and authorization, things like schema validation, XML schema validation, JSON schema validation, or any other threat validation logic. All sorts of things can be done at this API management layer. And then let's take the aspect of transformation. So assume that you have an application which talks JSON, and you have, let's say you have a legacy service which talks XML. Now you could place an API management layer in between and do this transformation from JSON to XML so that both parties can communicate. So it's not the only sort of transformation you could do. You could do any sort of thing like removing a header, modifying a header, adding a header, or modifying, transforming the payload. All sorts of things like this can be done at the API management layer. And then we also briefly looked at rate limiting. So rate limiting also can be done based on various conditions. For example, based on user, you provide a rate limit, or based on an application, based on the incoming header or the IP. So all sorts of uh, rate limiting policies can be done at an API management layer. And also analytics. So analytics would, the API management product would provide a portal where you could go and see all those charts and understand what's happening for your APIs. And another aspect is developer onboarding. So assume that your organization has like lots of services, right? So now when the uh, application developers who wants to consume these services, it's difficult for them to find out what the relevant APIs are. So this is a portal where the application developers can come, find out the APIs they need, search based on different keywords, and then read the documentation and generate test case, and also try out at the portal itself and see how the response is. So these sort of things are typically provided by an API management platform. So as I said, this is not an exclusive list. There are various other things that you could do. All right. So now about GraphQL API management. So why do we have to talk about GraphQL API management separately? Is because of this reason. So when we were first inquired by our customers regarding whether our API management platform supports GraphQL APIs, our obvious answer was a yes, because we know that okay, most of the GraphQL APIs talk HTTP, and we could essentially treat a GraphQL API as a single resource REST API. So we said yes, and obviously it worked as well. Uh, so so that was okay, but later we realized that most of our features that we had provided in our API management platform were more tailored towards the more prominent APIs that were there during those days, which is REST. So intentionally or unintentionally, those features were more tailored towards REST. So applying those features to GraphQL now was a difficult task. It wasn't working as expected. So we realized that we need to redesign our platform so that we could use those features for GraphQL APIs as well. So what I'm gonna do next to explain this is I'm gonna componentize a typical API management platform. So usually there are several components associated with an API management platform. So one of the main components is the gateway. So this is where the runtime traffic flows through, and if this component is down, it means that the client cannot reach the service. So this is one of the main components. Then you have various types of portals. So this is for various stakeholders. I will explain each of them in the upcoming slides. And then you also have an analytics engine which provides this portal and summarizes this data in an understandable manner. And there are other components as well, but I'm just going to focus on these things for clarity. Right. So first of all, I'm going to choose this API developer portal. So this is the portal where an API developer from your organization would log in to create this API, the interface. So for GraphQL APIs, the first thing we provided was the ability to import the GraphQL schema file and create an API. So for REST APIs, we had this feature where you could import the Open API specification file or the Swagger file, and you could just create the API. So similarly, the for GraphQL APIs, what we did was to give the ability to import the schema file and then create. And then an interface where you could filter out all the operations available in the API. So it will categorize them into queries, mutations, and subscriptions, so that the API developer understands like, okay, what are the operations that he's going to expose to the consumers. And then the ability to view the schema file that was used to create the API and also to download it. This is important because uh, this portal is not a place where a single person logs in. This is a shared space. So multiple employees from your organization would have access to this. So it is important for them to understand that what schema file was used to create a particular API. So I mentioned about rate limiting. So this is an example where one of our features were more tailored towards REST API, right? So we had this feature where you could specify rate limits for each resource. For REST API, let's say you had slash search and slash by. So for slash search, you could say it's 100 requests per minute, and for slash by, you could say 50 requests per minute. Now, if you just apply it as it is for GraphQL APIs, it's not gonna work because GraphQL just has a single endpoint. So the sensible thing to do here was to uh, provide these rate limiting policies per operation. So for each operation, you could say this is the rate limit that you wanna allow. So similarly, operational wise, authorization scopes. So you could categorize your user groups into two uh, groups, and for example, a primary example would be separating out the users who could do read and write operations. So for queries, you could set a specific scope, and for mutations, you could set a specific scope. So only those users will be able to get the token with that scope from the API management platform. And then another example is the ability to enable disable security for each operation. So you'd have come across situations where you just want to expose a single operation in your GraphQL API, and you want to do it without a token. It has to be anonymous. You don't have to log in to invoke that particular operation. For example, a search operation. So you could easily toggle the switch and say which operations should have authentication and which operations shouldn't have. Uh, so I hope many of you are aware of the GraphQL specific security challenges, right? So we have things like infinite depth attack, and then complexity attacks, and then batching attacks. So these were not known to the rest world, right? So these were like very unique for GraphQL APIs. So I'm aware that many of the GraphQL service implementations provide some support to mitigate these things. But if an API management platform can do these things, it means that the attacks won't even reach your service layer, right? So we could just stop at the API management layer if the API management layer can detect these attacks beforehand. So we provided a capability where you could set uh, complexity values for each field uh, through the portal, so that the gateway, the runtime, can calculate the incoming queries complexity based on the value that we have provided here. So how it blocks or allows the call, I'll explain it in the upcoming slides. Right. So then we have another portal called the application developer portal. So this is where people log in to find out the available APIs uh, that are available to consume. So the first thing we provided there was to filter out GraphQL APIs from the rest. So that is what you see here. And it is also important for them to understand what kind of operations are available in the GraphQL API. So a listing which shows that. And also the ability to download the schema file. So this is important because once you download the schema file, you could configure your GraphQL clients uh, with the schema file. So most of you would have seen this. So this is the GraphQL UI, the GraphQL tryout tool. So when we first started GraphQL API management, we did not have this. What we had was the Open API tryout tool, the Swagger UI. So we expected the GraphQL application developers also to use that to try out the APIs. But then we realized that the user experience provided there is not that good. So in a subsequent release, we embedded the GraphQL UI into the portal so that the developers get the same experience as trying out a direct GraphQL service. So we saw in the API developer portal, the API developer was able to assign complexity values. So it is important for the application developer to understand what sort of complexity values each field has, so they can tailor their queries also accordingly. All right, so we have another portal called administrators portal. So this is the portal where the administrators log in to create all sorts of policies like rate limiting policies or any other policy that governs the whole API management platform. So this is where rate limiting policy is also created. So usually what we have with the rate limiting policies, a policy based on request count. What it would say is just allow only 500 requests per minute. But we know that for GraphQL APIs, a rate limiting policy just based on count is not going to be sufficient because of the nature of because you can ask any amount of data from a single request. So what we did was we embedded two other parameters called the maximum depth, which can be allowed, and the maximum complexity, which can be allowed. So once this policy is created, then the API developers can attach this policy to their API, and also for a particular subscription where an application developer would subscribe to an API. Then it means that then the gateway can look into the incoming query and calculate the incoming query's depth or complexity, and then cross-check it with these values, the maximum threshold, and block it or allow it. So this is also a good place where you could monetize your APIs. You could provide higher values for premium prices, and so that the application developers have to choose pay more to use a higher depth or complexity value. So this is the gateway then. So as I said, the gateway was like tailored in a way that all the policy operations apply per resource. So we did redesign everything so that it could be applied per operation, and the ability to look at the incoming query and calculate the depth and calculate the complexity. And also one other thing I would say is to the ability to count the number of operations available in the incoming query. That will help you to detect batching attacks. And last but not least, subscription. Uh, so we know that you need some level of protocol level support for GraphQL subscription, like WebSocket. So if you should check whether the gateway supports these kind of protocols. Otherwise, you'll be only limited to expose GraphQL services which supports only queries and mutations. Okay, so the last part is analytics. So analytics again, most of our portal UI charts were designed in a way where all those counts or metrics were given based on resource. So we redesigned those things to support per operation. So for each operation, you could see how many number of requests were received, and also identify latency variations. When you have like multiple operation, how does it vary? And when you have a single operation, how does the latency vary? So that you could identify if there is any problematic area in latencies. And if any of your operations that you have exposed have not got any requests, then it could mean that you could retire it. So those kind of things can be decided from the analytics portal. So this is a screenshot of the analytics portal. So here it shows how the latency varies when you have the countries operation and the languages operation. So this is a screenshot of the usage summary. So this shows that when you there are 5 requests from when you have countries and languages, and 3 requests when you have just countries. All right. So to summarize, uh, we saw what API management means, and that it is a common requirement for all types of APIs. It's just not for REST or GraphQL. Whatever APIs, it is a common requirement uh, for all sorts of services. Then we also saw how you could just expose your GraphQL API endpoint in an API management platform which does not have any first-class support for GraphQL APIs. But we also saw what sort of things that you miss out when you settle for something like that, because by redesigning these features to match GraphQL APIs as well, you could reap a lot of benefits. So I hope the message was clear. You understood what API management means, and uh, what sort of things that you can expect from GraphQL API management. And if there are any other things that you would like to see in the API management platforms that support GraphQL APIs, let us know. We could include them in our products. And yeah, so you could just download a product and see, try out. So it's all completely open source. It's free to use. So this is a Slack channel if you want to engage in any discussion. These are our GitHub URLs. So you could contribute it if you have some time. So the slides are already available in the GitHub issue, so you can go download it and visit these links. So one more thing, we are giving away two free ebooks. So the one on the left is called API Automation and Scaling. So you could just download it by visiting this link and filling up this form. And on the right, you have a book, Microservices Security in Action. So this is authored by Prabhat Sirivardhan and Vandas, senior employees of WSO2. So if you want the book on the right, you could send me an email and I will send you over a voucher code, which you can use to download the book for free, the ebook version. Right. So if you have any questions, you can ask.
Yeah, I have a question. Thank you, Fazlan, for your presentation. I wonder how this API management platform, how well it supports WebSockets. We mostly connect to GraphQL through WebSockets. Can we do that rate limiting and that complexity limiting stuff?
Yeah. So, so right now, at the current state of the latest release of WSO2 API Manager, we haven't supported subscriptions yet, but the implementation is right now going on, and it will be available in the next release. The thing is, we already supported WebSocket APIs as a separate API list even before GraphQL API support. So you could go and create a WebSocket API at the API management portal, and that works over WebSocket. So now what we're trying to do is, since for subscriptions you need a WebSocket, we are trying to reuse that protocol within the API management platform so that the queries and mutations work via the normal path, normal HTTP path. And for subscription, it internally routes to the WebSocket endpoint so that all three will seamlessly work together. So we are already working on it. The immediate next release would have this feature.
Cool, thank you.
I have a question. So is there a way to, you showed us that there's a way to see which resources kind of slower, like countries or other resources are slow. And to me, it is, I can understand it from like a REST API perspective, but from the GraphQL API perspective, I think I would be more interested in, are there any particular queries that are slow? And that's something we recently had. For example, we discovered that some particular queries that our front end makes sometimes really slow and we need to optimize a little bit. So is there a way to discover this kind of pain points, slow queries with your tool?
Yes, so the existing portal widget, what it does is you could choose the API and then you can choose each operation and see how the latency varies. So it just not directly provide you a metric saying that these were the slowest API, slowest operations, but you could manually choose each operation and see whether there is a problem. Or you could choose multiple operation and see whether there is a problem. So there is no like currently we don't have a way to directly say these were the slowest queries. Yeah, but I get your point. That would be a great metric to have. Yeah.
But generally, do you store all the queries that came through the gateway?
Yes, all queries, information regarding all the incoming requests will be published to a separate analytics server, and what that does is it does this thing called real-time processing. For example, things like these solutions like Kafka. We use a solution called WSO2 Siddhi, which is a streaming engine. So what it does is it just summarizes the data that comes in and persists it into the database in a suitable format. For example, every 1 minute it counts how many requests were received from this particular API for this operation or resource and persist in the database.
Thank you. And does your API management platform have a GraphQL API?
No. So I think you're asking about the
like can I, if I want to use it to, maybe I want to subscribe on some things, like in the future I want to subscribe in some other products on slow queries once you start giving them that. Yeah, I think it was more like a random question, but okay.
Yeah. So all the product administration things, so whatever that you could do in the portal can be done via the REST API. So that's what we have been having for a long time. So for programmatically, if you want to create APIs, subscribe to them. So you don't have to use the portal. It's not a must. Yeah, but this is for these functionalities currently only supporting the REST API. We don't have a GraphQL API for product administration.
Yeah, makes sense. Okay.
I have a question about if you want to use the authorization in your business logic. So, for example, like you may condition, like maybe you want to conditionally return some data depending on your access level. For example, like a product has a price, it also has a cost price, and an administrator can see a cost, like can request the field for cost price in the GraphQL query, whereas a consumer is not able to. So if I want to be able to use authorization as part of the decision making in my business logic,